designing an antibiotic, you wouldn't create a drug that destroyed DNA, for example, because that's something that both humans and bacteria share in common. It would kill the bacteria all right, but it might kill us too. So many antibiotics work by attacking the bacterial cell wall, something bacteria have that we don't. Antifungals can attack the unique cell walls of fungus. Pesticides can work by attacking the special exoskeleton of insects, but fighting cancer is harder, because cancer cells are our own cells. So fighting cancer comes down to trying to find and exploit differences between cancer cells and normal cells. 40 years ago, a landmark paper was published showing for the first time that many human cancers have what's called absolute methionine dependency, meaning you can grow normal cells in a petri dish without giving them the amino acid methionine. Normal cells thrive, but without methionine, cancer cells die. Normal breast cells, for example, grow no matter what, with or without. But here's leukemia cells. They need that extra added methionine to grow, or they just flatline. What does cancer do with the methionine? Tumors generate gaseous sulfur-containing compounds with it that specially trained diagnostic dogs can actually pick up. There are mole-sniffing dogs that can pick out skin cancer. There are breath-sniffing dogs that can pick out people with lung cancer, pee-sniffing dogs that can diagnose bladder cancer, and yes, you guessed it, fart-sniffing dogs for colorectal cancer. Doctors can now bring their lab to the lab. Gives a whole new meaning to the term PET scan. Anyway, methionine dependency is not just present in cancer cell lines in a petri dish. Fresh tumors taken from patients show that many cancers appear to have biochemical defects that makes them methionine dependent, including some tumors of the colon, breast, ovary, prostate, and skin. Chemo companies are fighting to be the first to come out with methionine-depleting drugs, but since methionine is sourced mainly from food, a better strategy may be to lower methionine levels by lowering methionine intake, eliminating high methionine foods for cancer growth control. Here's the thinking. Look, smoking cessation, consumption of diets rich in plants, and other lifestyle measures can prevent the majority of cancers. Unfortunately, people don't do them, and as a result, each year hundreds of thousands of Americans develop metastatic cancer. Chemotherapy cures only a few types of metastatic cancer. Unfortunately, the vast majority of common metastatic cancers, like breast, prostate, colon, and lung, are lethal. We therefore desperately need novel treatment strategies for metastatic cancer, and dietary methionine restriction may be one such strategy. So, where is methionine found? Particularly chicken and fish. Milk, red meat, and eggs has less, but if you really want to stick with lower methionine foods, fruits, nuts, veggies, grains, and beans. In other words, methionine restriction may be achieved using a predominantly vegan diet. So why isn't every oncologist doing this? Despite many promising preclinical and clinical studies in recent years, dietary methionine restriction and other dietary approaches to cancer treatment have not yet gained widespread clinical application. Most clinicians and investigators are probably unfamiliar with nutritional approaches to cancer. That's an understatement. Many others may consider amino acid restriction as an old idea, since it's been examined for several decades. However, many good ideas remain latent for decades, if not centuries, before they prove valuable in the clinic. With the proper development, dietary methionine restriction, either alone or in combination with other treatments, may prove to have a major impact on patients with cancer.